seems like some people are not able to join the meet, ma'am. They've been trying for long.
But the request is not showing here, ma. 67 students have joined, but they can log out and again they can raise the request.
Okay.
Huh? Ask them to log out and join the meet again.
Okay, ma'am.
Have all of you noted? Yes?
No, ma'am.
Okay. So this program is mainly for your signed and unsigned multiplication. Okay. So here I have used normal multiply instruction, MUL, and we have separate instructions, multiply instructions for unsigned and signed numbers. So that multiplication is called unsigned long multiply, and another one is signed long multiply. So we have three instruction under multiplication operator. Okay, MUL, unsigned MUL long, signed MUL long. Have you all noted?
Yes, ma'am.
Yes. Okay. See, according to first two instruction, your R0 is holding 02 and R1 is holding 04. Okay. So I am going to multiply the content of R0 by R1. Okay. So what it will do is it will perform only 32-bit multiplication. Okay. Even if the result exceeds a 32-bit result, only it will return your lower order result. That is LSB result alone. Remaining 32-bit will be discarded. So that is the operation of this MUL. Okay. Can you understand?
Yes, ma'am.
Yes, ma'am.
Suppose if you really need to, that is want to multiply large numbers, we will have long multiply instruction. So the basic multiplication instruction discards the upper 32-bit of the product and gives you the bottom 32-bit as the result. So you will get only MSB alone. Okay. So I have taken simple data, that is 02 and 04. After multiplication, your R2 will hold this value. Just it will perform simple multiply operation. 2 into 4, you will be getting this number and that will be holded by R2. Okay. And next, I am going to move 32-bit. I am going to handle 32-bit number into R3 register. Okay. So your R3 holds. So this value 32-bit value, and this is going to be your multiplier 77. Okay. So I am going to multiply this 32-bit number by 77. And I am going to use simple multiply operation. So what is the answer? Just you do it with the calculator and tell me. So when we use this MUL instruction, your processor always thinks that this is the unsigned number. Okay, when you are going to use this MUL, so this inputs, that is these inputs are going to be unsigned numbers, not signed numbers, according to your processor understanding. So here you have to give unsigned values alone. Is that clear, students? Is that clear?
Yes, ma'am.
Okay. What is the answer? Do it in the calculator and tell me. So I'm going to multiply this 32-bit number by 77. According to your processor understanding, these two numbers are going to be unsigned numbers. Okay. So after multiplication, you will be getting this 64-bit result. Okay. All of you getting this? Just you do it in the calculator, hexadecimal calculator. All of you getting this?
Yes,
Say,
ma'am.
okay. So using this simple multiply answer, the multiply instruction, we are able to get only 32-bit value alone. So after execution, your R5 holds this 32-bit value. Remaining bits will be discarded. This 76 will be discarded. Is that clear?
Yes, ma'am.
Okay, next I am going to extract this 76. For that, you need to use this unsigned mul long. So for that, we need to use these two registers. We have two source register and we need to use two destination number, the register, to extract your 64-bit result. Okay, and this R4 holds upper 32 bits. Please note it down, upper 32 bits. And this one holds lower 32 bits. So this is for upper. And this is LSB. Okay. See, after execution of this particular instruction, your R4 holds this 76 and R5 holds this value. Is that clear, students?
Yes.
Say something.
Yes, ma'am.
Okay. So after multiplication, your R4 holds your upper 32-bit. This is your upper 32-bit. 76 will be holded by R4 and remaining bits will be holded by R5. Okay. So for these two inputs, I am going to use signed long multiply. So when we use this signed long multiply instruction, your processor always thinks that is your inputs are going to be signed numbers. So your processor interprets that your inputs are signed numbers. Is that clear? So is this a negative number or positive number? Just look at your 32-bit and tell me.
R3
So
is
just
negative and R4 is positive.
positive. So use this calculator, your online calculator. Okay. So this value is, that is your FFF 10 is minus 28560. So just use this calculator and find out the exact value for this one. For this one, minus 240. So open this calculator and enter this number and find out the signed value for this particular thing. So exact signed value for this one is 240. Okay, decimal value. For 77 is a positive number, so 119. So your processor is going to multiply minus 240 by 119. Okay. So when we use this signed long multiply instruction, we are supposed to get this answer, negative answer. Okay. That is minus 28560. Okay. So I'm going to multiply this number by 77. So we are supposed to get this value, that is 28560. Okay. Okay.
Yes, ma'am.
So for this, actually, according to your unsigned multiply answer, what is the LSB? 4x9070. But we have to get this answer. So user responsibility is that we need to interpret the result. Okay. So we will be for this particular value, the signed value is 6F90. Just you do it, because I am not able to open this particular website using this camp Wi-Fi. Just you open this. So exact signed number for this value is minus 6F90. So that is the decimal value for 28560. After multiplication, you are supposed to get this answer. So for this value, the hexadecimal answer is 6F90. So after multiplication, we are going to get the 2's complement of this particular value. Okay, we are going to get the 2's complement of this minus 6F90. Okay. So for this, we have to take the 2's complement. Okay, 6F90. So take the 2's complement. So this answer you are going to get the you are going to get this value after the signed multiplication. Are you able to follow? Actually, after multiplication, okay, according to your inputs, your processor interprets that the number is the negative number. Okay, but it will perform the multiplication by using these two hexadecimal numbers. We are supposed to get this answer, but in your Keil microvision, when you simulate this code, you are going to get this value. How we interpret the result means we have to take the 2's complement and check the result. Okay, so but we are supposed to get this value 6F90. So take the 2's complement, we are getting this answer in our Keil microvision. Is that okay? Is that clear?
Yes.
What is your MSB? What is your MSB? We are supposed to get this answer. We are supposed to get this answer. We need to take 2's complement and check your results. Okay. So first MSBs are first 4 bits are filled with 0. When we take 2's complement, we will be getting so this is going to be our MSB, this is going to be our LSB. Is that clear, students? புரிஞ்சுதான் பாருங்க. ஃபர்ஸ்ட் இப்போ இதோட இன்புட் வந்து இதோட சைன்டு வேல்யூ -240, இதோட சைன்டு வேல்யூ டெசிமல் வேல்யூ 119. ஸோ இதோட ஈக்குவலண்ட் சைன்டு வேல்யூ -240. இதை ரெண்டையும் நான் மல்டிப்ளை பண்ணும்போது I have to get this 28560. So equivalent hexadecimal for this number is 6F90. So we are supposed to get this answer, but your processor will take hexadecimal value and perform signed multiplication, and the result will be in 2's complement form. Since we are giving 2's complement input, result will be in 2's complement form. So you take the answer for that is 6F90, take 2's complement and check your answer. Is that clear? நீங்க இங்க பாத்தீங்கன்னா F9070 நான் கொடுத்தேன்னா என்னோட ஆன்சர் வந்து 6F90. So you have to take 2's complement for this value and check your answer in Keil microvision. So what is your answer? So this is your MSB and this is going to be your LSB. Is that clear? I will demonstrate. You can understand clearly. Okay. See, SMUL instruction interprets the value from Rn and Rm as 2's complement signed integers. Okay. Is that clear, students? Yes or no?
Yes,
Okay.
Yes, ma'am. Yes, ma'am.
So it will perform this one 240 by 119. We are supposed to get this answer, but in your Keil microvision, you will be getting the 2's complement result. So processor does not know whether we are multiplying signed or unsigned value. Only programmer know how to interpret the results of an operation. So you have to take the 2's complement result and check your answers with the Keil microvision. Okay. So next instruction, I'm going to load this 32-bit value into R6 and this 16-bit value to R7, and I will be using this simple multiply instruction. So after execution, your R8 holds this value. When we use simple multiply instruction, the 16-bit result will be discarded. Okay. Again, I'm using long multiply. I'm able to extract this 5, 7, B5. So after execution, your R8 holds upper 32-bit and R9 holds lower 32. Is that clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Please note down all the answers, because you have to infer the results. Okay. So just you note down this table for verification of the results. So you just look at the code. I have used normal MUL, simple MUL instruction. Is my screen visible, ma? Keil
Yes,
microvision.
yes,
Okay.
yes.
So I am going to simulate this program using Keil microvision, unsigned multiply and unsigned multiply long. Okay. So what is your first instruction? I'm going to load the 02 into R0. Okay. After execution, your R0 is loaded with 02. And I'm going to execute next instruction, move R1, comma 04. Okay. And next I'm going to execute MUL. After execution, your R2 is updated with 08. Are you able to see this? See?
Yes, ma'am.
Okay. So your R2 is updated with 8. Okay. And next I'm going to execute to move instruction. After execution, your R3 is loaded with this value, 32-bit value, and R4 is loaded with 77. I'm going to execute simple MUL instruction. After execution, your R5 is updated with 4x9070. Okay. And your MSB will be discarded. 76 will be discarded. Okay. And next I am going to use execute unsigned long multiply instruction. For that case, your MSB is loaded into R5 register and LSB is loaded into R6 register. So I can able to extract both LSB and MSB using this unsigned long multiply instruction. Is that clear, students? Is that clear? Okay.
Yes, ma'am.
Next, I am going to use this signed MUL instruction. So that case, you have to get 8x. 8x will be your MSP and 2's complement answer will be the LSP. So the same value, that is FFF9070. So I'm going to execute that. Look at this, R5 is updated with 8x and R6 is updated with 4x9070. Okay. So here only programmer should understand how to interpret the results of an operation. Okay. So manually you do the calculation, and after that you take 2's complement of that answer and check the answer using your register content. Okay. And next one is I'm going to load these two values into R6 and R7 and perform a normal multiply instruction. Okay. So your MSP will be discarded and long multiply. So the result will be stored in R9 and R8. Okay. So your R8 holds this value and R9 holds this answer. So R9 holds this value and R8 holds this. So your R8 is holding this 16-bit value and R9 is holding this value, 32-bit value. Is that clear, students?
Yes, ma'am.
Yes, ma'am.
Okay. So next one is the division instruction. Just you note down the code. So we have two instructions under division operate. One is unsigned div, another one is the signed div. So only we have two. So generally we can store quotient value. The remainder will be discarded using unsigned div and signed div. So first your R0 is loaded with 0, 2 and R2 is loaded with 4. I'm going to divide R2 by R0. So this instruction divides the value in R2 by the value in R1 and puts the result in, that is puts the quotient in R3 register. So 4 divided by 2, your answer will be 2. Your R3 is holding this value. 2. Your quotient will be, remainder will be discarded. So if you want to extract the remainder, for that we need to write separate algorithm. So that can be done by programming. Okay. So separate routine has to be written for extracting your remainder value. So what is the next one? Just you find out the answer for this. Tell me the answer. Students, are you able to follow?
Yes, ma'am. Ma'am, will it be 1?
Okay. Yes. R2 by R1. So what is the content of R2?
4.
4. Okay. What is the R1?
3.
3. Okay. So the answer is 1. So your R4 holds 1 after execution of this particular instruction. So when we divide 4 by 3, we get quotient of 1 with the remainder of 1. Okay. So however, we need to remember that these are integer divisions, which means any remainder from the division is simply discarded. So integer division simply discards the remainder. So next case is the worst case example. Suppose if we divide 3 by 4, what will happen? So that is the this instruction, you div R5, R1, R2. That is R1 by R2. So R1 is 3 and R2 is 4 and R1 is 3. 3 by 4. What will happen? What is the result?
0.
0.
0.
0.
So the result is 3 by 4 is 0.75. We get a fractional, we will get a fractional value. Since a fractional part of the result is discarded. So 3 by 4, the answer will be 0. After execution, your R5 holds the 0.
Yes, ma'am.
Okay. So next, I am going to load this 32-bit value into this R6 register and R7 05. So the 05 is going to be your divisor. I am going to use this unsigned div instruction, that is R6 by R7. So divide this number by 5. Do it in the hexadecimal calculator and check your result. You are going to get this value. After execution, your R8 holds this value. So these two are decimal equals. Is that clear, students?
Yes, ma'am.
Yes, ma'am.
Okay. So your R6 is going to be a very large positive value. Okay. When we divide this, we are getting this answer. Okay. For these two operands, okay, I am going to use this signed division. So what will happen? So what your ARM core will do?
2's complement, ma'am.
Okay, so if we consider the value in R6 to be assigned 2's complement value, it is a small negative number, okay? So just you do it in the calculator and find out the equivalent negative value. For this one, the negative value is 256. But this case, it is a larger value, okay? But in case of signed number, it is a very small value, that is minus 256. Just you do it in this calculator, okay? So 256 by 5. So we are going to perform signed division using this instruction. After signed division, we are going to get this answer. So that is equivalent to your 51. Okay. So in your Keil simulation, we are going to get this value. How to interpret the result means we have to take 2's complement of this particular value, CD. That is all X with CD. So look at this. So your answer is 6FCD. So CD I am going to take 2's complement. What is the answer? 33 is the hexadecimal. Equivalent value is 51H. So 51H decimal is the exact answer. See, this is your answer. இதுதான் உங்களுக்கு Keil வரும். நீங்க எப்படி இன்டர்பிரட் பண்ணணும்னா just take 2's complement of this particular value. So write it binary, find out the 2's complement. After calculating the 2's complement, this is going to be your answer, 33 hexadecimal. Convert that value into decimal. So that value is 51. So when we divide this 256 by 5, the answer will be 51D minus 51. So just compare these two values. So your processor is going to divide, that is perform unsigned operation. For that case, we are going to get this answer. Suppose if the processor is going to perform signed operation, for that case, we will be getting this answer. So we have to interpret the results by taking 2's complement. Is that clear?
Yes, ma'am.
CD க்கு 2's complement எடுத்தீங்கன்னா 33 கிடைக்கும். அப்ப 51 is the right answer. இந்த மாதிரி தான் interpret பண்ணணும். For FFCD, what is the answer? Answer is the 33, decimal 51. In this way, we can interpret the result. Is that clear, ma? So can you identify the difference between signed division and unsigned division? So these two are very important operation in Keil microvision. So signed abdina, you will be getting some answer, okay? From that answer, you have to interpret the result by taking 2's complement. So that is the concept behind all your signed operation. Is that clear? Just you note down all the answer. I will simulate this code in the Keil microvision. Okay. So I'm going to simulate this division program. Okay. So after execution of first instruction, your R2 is updated with this, that is loaded with 02. Are you able to see the screen? Keil microvision screen? Okay.
Yes, ma'am.
R naught is loaded with 02, okay? And R1 is loaded with 4. I'm going to divide 4 by 2, okay? So again, it is multiplying, I think. So. One second. So what is the answer? After division, your R3 holds. What is the answer, ma? R3 holds. So R3 is holding 2, okay? And next, R1 is now loaded with 03 and again dividing. Now your R4 is holding 1, okay? 4 by 3, okay? And next, 3 by 4. So your R5 is holding 0, okay? And next I am going to perform unsigned multiply. For that I am loading R6 and R7 register with some numeric constant. So after division, your R8 is holding this value. So this is the answer for your unsigned division, okay? And next I am going to perform signed division. For that case, you will be getting this answer. So for that, you need to get need to check the exact answer. அதுக்கு நீங்க என்ன பண்ணணும்? First you take 2's complement of this result. So அதை வச்சுட்டு you can interpret the results. Is that clear, students? So you complete all the programs. That is your 32-bit addition, 32-bit multiplication, division, okay, subtraction, and logical operation, okay, and using LDR, get the data elements from data section, and you try all these code. That is addition program, okay, and subtraction, the addition, subtraction, multiplication, and division. So you have to submit all these programs by tomorrow. So upload your output document, okay, in the Google Classroom by tomorrow. Is that clear?
Yes, ma'am.
Okay. Okay, ma, thank you. I will take your attendance from the Google Sheet, okay? So do you have any clarification in this?
Thank you, ma'am.
Okay, ma,
No,
thank you.
ma'am. No
Okay,
doubts.
thank you.